welcome to lecture series of Mathematics 1. This is Hitesh Manglani, Assistant Professor at LG Institute of Engineering and Technology. Today we will discuss about Unit 2 of Mathematics 1, that is Indeterminate Forms. So total there are 7 indeterminate forms. First form is 0 by 0, then second form is infinite by infinite, then third form is 0 into infinite, then fourth form is infinite minus infinite, then fifth form is 1 raised to infinite, then sixth form is infinity raised to 0, and the seventh form is 0 raised to 0. So these are called indeterminate forms because their value is not determined. So to solve this type of forms, Lapid Rule is applied, and Lapid Rule is applicable for these two forms, that is 0 by 0 and infinite by infinite. Now what about other forms? So for other forms, we will have to convert all other forms into 0 by 0 or infinite by infinite so that Lapid Rule can be applied. Now first of all, we will discuss first form, that is 0 by 0. So let us discuss example related to that. First example, evaluate limit x tends to 0 sin x divided by x. So you know that limit theta tends to 0 sin theta divided by theta is equal to 1. But we will prove this result using Lapid Rule. So here, replacing x by 0, so it will be sin 0 and value of sin 0 is 0. And if we replace x by 0, then here it is 0. So it is 0 by 0 form. Now, according to Lapid Rule, we have to take derivative of numerator and denominator individually. So first of all, we will take derivative of sin x. So derivative of sin x is cos x. So here we will write down cos x. Then divided by derivative of x. So derivative of x is 1. Okay. So now replacing x by 0 here. So it will be cos 0 divided by 1. And value of cos 0 is 1. Okay. Therefore we got the result, limit x tends to 0 sin x divided by x is equal to 1. Now let us discuss second result, that is limit x tends to 0 tan x divided by x. So you know that limit theta tends to 0 tan theta divided by theta is equal to 1. Now we will prove this result using Lapid Rule. So here if we replace x by 0, then value of tan 0 is 0, and here if we replace x by 0, so it is 0. So it is 0 by 0 form. So by Lapid Rule, we have to take derivative of numerator and denominator individually. Okay. So derivative of tan x is sec square x, and derivative of x is 1. Now we will replace x by 0. So here it will be sec square 0, and value of sec 0 is 1 because value of cos 0 is 1. Okay. So it will be 1 square and it is 1. So limit x tends to 0 tan x divided by x is equal to 1. Now let us discuss third example. Evaluate limit x tends to 0 e raised to x minus 1 minus x divided by x squared. Okay. So here first of all, we will have to check whether this is 0 by 0 form or not. So replacing x by 0, so here it will be e raised to 0 and value of e raised to 0 is 1. So 1 minus 1 is 0 and here it is 0. Okay. And denominator is also 0. So this is 0 by 0 form. So we can apply Lapid Rule. So by Lapid Rule, we will take derivative of numerator and denominator individually. So derivative of numerator, that means derivative of e raised to x. So derivative of e raised to x is e raised to x. Then derivative of 1, that is constant term. So derivative of 1 is 0. Then derivative of x is 1. So here we will have down minus 1. divided by derivative of x square. So derivative of x square is 2x. So again we will check whether it is 0 by 0 form or not. So for that, replacing x by 0, so e raised to 0 is 1, 1 minus 1 is 0, and denominator is also 0. So it is still 0 by 0 form. So again we will use Lapid Rule. So using Lapid Rule, taking derivative of numerator and denominator separately. So derivative of e raised to x is e raised to x, and derivative of 1, that is constant term, so derivative of constant term is 0, divided by derivative of x is 1, so 2 into 1, so it will be 2. Now we have eliminated this 0 by 0 form. So now just replacing x by 0, so here it will be e raised to 0, e raised to 0 divided by 2, and value of e raised to 0 is 1, so 1 divided by 2. So this is our final answer of this question. Now let us discuss fourth example, that is evaluate limit x tends to a log x minus a divided by log e raised to x minus e raised to a. So here first of all we will replace x by a. So here if we replace x by a, so here a minus a, that is 0. So here we will obtain log 0, and the value of log 0 is minus infinite. Okay. Now again here replacing x by a, so here e raised to a minus e raised to a. So here it will be 0, and value of log 0 is minus infinite. So it is minus infinite divided by minus infinite. So can be written as infinite by infinite. So given form is infinite by infinite. Okay. So we can use Lapid Rule. So by Lapid Rule, taking derivative of numerator first, so derivative of log x minus a will be 1 divided by x minus a, because derivative of log x is 1 divided by x. Then taking derivative of bracket, so here derivative of x is 1 and a is a constant term, so derivative of a is 0, so into 1. Okay, then divided by, now we will take derivative of denominator, so here derivative of this will be 1 divided by e raised to x minus e raised to a, because derivative of log x is 1 divided by x. Then taking derivative of bracket, so here derivative of e raised to x is e raised to x, and derivative of e raised to a will be 0 because it is a constant term, so here into e raised to x. Now simplifying this, so it will be limit x tends to a e raised to x minus e raised to a divided by e raised to x in bracket x minus a. Now again we will have to check whether it is 0 by 0 form or infinite by infinite form. So for that, replacing x by a, so here e raised to a minus e raised to a, so it will be 0. Okay, divided by, if we replace x by a, so a minus a will be 0. So 0 into e raised to a will be 0. So it is 0 by 0 form. So again we will use Lapid Rule. So for that, taking derivative of numerator, so here derivative of e raised to x will be e raised to x, and derivative of e raised to a will be 0. Okay. Now we will have to take derivative of denominator. Here this is a function of x and this is also function of x. So we will use product rule. So for that, first of all, e raised to x constant, then derivative of x minus a will be 1 minus 0, because derivative of x is 1 and this is a constant value, so it is 0, plus then x minus a is constant and derivative of e raised to x will be e raised to x. Clear? Now we will replace x by a, so here it will be e raised to a divided by e raised to a, and if we replace here x by a, so a minus a will be 0, so no need to write down this term. So e raised to a divided by e raised to a, so answer will be 1, because e raised to a divided by e raised to a will be cancelled out. So final answer will be 1. Now let us discuss fifth example, that is evaluate limit x tends to 1 minus x into tan pi x divided by 2. Clear? So first of all we will have to check whether it is 0 by 0 form or infinite by infinite or 0 into infinite. Okay, so for that replacing x by 1 here, so 1 minus 1 it is 0, and here tan pi by 2, and value of tan pi by 2 is infinite. So it is 0 into infinite form. So in each example, first of all we will have to check the form of question. Okay, so here we will write down this as limit x tends to 1 minus x divided by cot pi x by 2, because tan theta can be written as 1 divided by cot theta. Therefore this can be written as 1 minus x divided by cot pi x by 2. Now if we check form of this result, then replacing x by 1, so 1 minus 1 is 0. Okay, and here cot pi by 2, and value of cot pi by 2 is 0. So now it is 0 by 0 form, so we can use Lapid Rule. So this way 0 into infinite form can be converted into 0 by 0 form. Okay, so we can use Lapid Rule. So taking derivative individually, first of all taking derivative of numerator, so derivative of 1 is 0, and here derivative of x is 1. So here it will be minus 1 divided by then derivative of cot theta. So derivative of cot theta is minus cos x square theta. So it will be minus cos x square pi x by 2. Okay, then into then coefficient of x, that is derivative of this pi x by 2 will be pi by 2, because derivative of x is 1. Okay, so if we simplify this result, then it will be limit x tends to 1. So this can be written as 2 divided by pi, and 1 upon cos x square pi x by 2 can be written as sin square pi x by 2, because sin and cosec are reciprocal of each other. Clear? And minus minus cancel out. So now replacing x by 1 over here, so it will be 2 by pi into sin square pi by 2, and value of sin pi by 2 is 1, so this will be 1 square. So 2 by pi into 1 square, so this will be 2 divided by pi. So our final answer will be 2 divided by pi. Now let us discuss sixth example. Evaluate limit x tends to 0, 1 divided by sin x minus 1 divided by x. So first of all we will have to check the form of the question. So here replacing x by 0, so value of sin 0 is 0, so this is 1 divided by 0, so 1 divided by 0 is infinite. Okay, here again 1 divided by 0, so it is again infinite, so it is infinite minus infinite form. So we will have to convert this form into 0 by 0 form. So for that, first step we have to take LCM, so it will be x minus sin x divided by x into sin x. Now replacing x by 0, so here it will be 0 minus sin 0, and value of sin 0 is 0, so in the numerator there will be 0. Then here if we replace x by 0, then it will be 0. So now it is converted into 0 by 0 form. So this way infinitive minus infinitive can be converted into 0 by 0 form. So now here if we use Lapid Rule, so here taking derivative of numerator, so derivative of x is 1 and derivative of sin x is cos x. Okay, and here we will use product rule, so x will be as it is and derivative of sin x is cos x, plus sin x will be as it is and derivative of x is 1. Okay, Now replacing x by 0, so here cos 0 and value of cos 0 is 1. So 1 minus 1, that is 0. So in the numerator it will be 0. And here if we replace x by 0, so here it will be 0 and value of sin 0 is 0. So it will be 0 by 0 form. So again we will have to take derivative of numerator and denominator individually. So here we will write down limit x tends to 0. Derivative of 1 is 0. Then derivative of cos x is minus sin x. But here it is minus sin, so it will be plus. So plus sin x divided by. Here again we will use product rule. So x will be as it is and derivative of cos x is minus sin x plus cos x will be as it is and derivative of x is 1. Okay. Then derivative of sin x is cos x. So here plus cos x. Clear? Now replacing x by 0. So here value of sin 0 will be 0. And here because of x this term will be 0. And here 0 plus cos 0 plus cos 0. And value of cos 0 is 1. So here it will be 1 plus 1. So 0 divided by 2. And 0 divided by 2 is 0. So answer of this question is 0. So in this lecture we have discussed examples related to 4 forms, that is 0 by 0, infinite by infinite, 0 into infinite and infinite minus infinite. Thanks for watching this video. I will see you in the next lecture.